And welcome viewers to the Daily Space Weather Show. We've got another awesome series of images and more space weather incoming, and it's just a fantastic time to be doing space weather. So thanks for tuning in to the Smash News Network, least busted name in news. This is the past 24 hours from the closest star, and guess what? Right down here early this morning, another coronal mass ejection is now headed Earth's way. That makes a total of 5. Yeah, 5 incoming CMEs, folks. So we're going to have an exciting few days of space weather coming up. We've also got a massive uptick in the radio flux and some heavy hitters rising over the eastern limb. So if you look over there on the left of your screen, you'll see some CMEs popping off over there. Those aren't earthly directed, but that's the most active portion of the closest star right up here in the northeastern limb. Some sunspots that aren't even visible yet from the Earth-facing portion of the solar system, the earthly portion of the solar system. There is 304 angstroms as well. And yeah, it's good times for space weather. And by the way, thanks to our new subscribers, our old subscribers, all of our subscribers, and of course the Smash team. We've recently reached 1 million views and 5,000 subscribers, so thanks to everybody for that. Next, we'll take a look at what's going on with earthquakes and volcanoes. So first of all, the Reykjanes Peninsula continues to inflate. So this is getting pretty creepy at Iceland. It's looking like there may be another major eruption in the offing. So there's a ground deformation map. Again, the ground continues to inflate, indicating that magma is accumulating underneath the ground. Subanosejima is erupting also Ibu. Don't forget Luitoli, Semeru, Merapi. Shishaldin now back on the list. Haven't seen Shishaldin for a while in the Aleutian Islands. Popocatépetl exploding. Santiaguido, Fuego, Nevado de Ruiz, Sabancaya. And let's get to earthquakes. So there are the past 90 days, and we're having an earthquake drought. It's official. This is an earthquake drought for 6 and 7 magnitude quakes. And there looks like there could be an earthquake watch for the west coast of the U.S., the North American Pacific Plate boundary. As we saw a 4.6 at California there. Now let me zoom in on that. So it's an earthquake swarm happening there and some significant shaking happening there. Check it out, a 4.8 there. 4.6 near El Centro, California. So these are the rest of the quakes of a 5 and greater magnitude. Philippines had a 5.4. Mid-Atlantic Ridge had a 5.3. Central Mid-Atlantic Ridge had a 5.5. Vanuatu had a 5.4 at depth, over 140 kilometers estimated depth. There's that 4.8 at El Centro, California. Is it the predecessor to a larger quake known as a foreshock? Let us know in the comments what you think. Are we going to see a large quake in California or somewhere on the western North American plate boundary? Largest quake of the past 24 hours was a 6.1 at the Volcano Islands region south of Japan there. That's 6.1 at extreme depth, nearly 250 kilometers for that quake. And that rounds out our list besides this 5.0 in the Band-Aid Sea, also at depth there, 152 kilometers estimated depth. And let's get back to some space facts. So check it out. We're going to show some filamentary activity here, and it's, yeah, that's not bad. So again, another CME headed this way. It's this one from down here. This one up here, not so much earthly directed. And let's talk some stats. The 10.7 centimeter radial flux now up over 200 at 209 solar flux units. 209 is the new radial flux number. A significant uptick in the radial flux. Continuing on, there is the 1-year graph. Again, radial flux now way up here at 209, approaching the highest levels we've seen for solar cycle 25. The black line is the radial flux, the red line is the sunspot number, the blue line is the AP index, and the time frame depicted there is the past year. Solon.info is where you can check it out yourself if you like. Next, a Space Weather Enthusiast dashboard forecasting major space weather coming in here. So it looks like the strongest impact is expected sometime around midday the 13th, which sounds like something I said on the 10th. So Yeah, so, hey, what can I say? It's the world's most comprehensive daily space weather content and the most detailed solar imagery you'll find in the known universe. So, yeah, major space weather coming in, and the latest impact is going to be on the 15th, so that's going to continue with geomagnetic storm conditions as another major impact is on the way from just this morning. We'll get to it. First, some Enlil spirals. So first we'll show NOAA's Enlil spiral, and you can see some co-interactive regions there being forecasted by NOAA. You can see a nearly direct impact there. So yeah, again, exciting times for space weather. That's NOAA's forecast. Multiple impacts. We've counted 5 in the past couple of days. Next, NASA's forecast, which is looking like NASA's under forecasting. I mean, what can I say? Facts. Not looking too good there, NASA. Next, Earth's magnetic moment from space, and we're going to talk about aurora viewing here since it's going to become more and more relevant. So there are the past 4 hours of Earth's magnetic moment from space. That depicts magnetohydrodynamic pressure. And yeah, things are fairly calm here at the moment. We still do have an elevated solar wind. So we'll get to that information here in just a moment. Again, that's the last 4 hours of Earth's magnetic moment from space to about 12 Earth diameters. Next, Earth's magnetic moment from the ground, and this ground magnetic perturbations map depicting geospace delta B changes to Earth's B field, the B field being the field going through the magnet, this magnet being Earth, is good at showing you where to see the aurora. So you can use that. We've demonstrated on the channel and taken video and photograph of aurora. So you can use that when geomagnetic storms hit. And you can also use the geoelectric map. So that's empirical data there from induction in the actual power grids of the U.S. and Canada. So when you see those lighting up, that's another way to expect the aurora overhead, as these things do coincide. Keep in mind the aurora can show up and disappear very quickly, so it is very time sensitive. But maybe check that one out. If you're trying to view the aurora, this might really help you. The geoelectric field map and the ground magnetic perturbations map doesn't hurt either. I think it's a little more accurate than the actual auroral forecast from the Space Weather Prediction Center, but let us know in the comments what you think. Next, KP index only at 0.67. KP 0.67 is the geomagnetically calm condition, as you can see. Yeah. Next, solar wind data. And ACE and Discover are pretty consistent here at the moment. Whoops, we've got the Discover. There we go, there's the ACE. I stand corrected. The ACE is actually showing a much less dense, a much more diffuse solar wind. Only 1 proton per cubic centimeter there, but a similar solar wind speed. So that's the ACE. Here's the Discover, which also orbits Lagrangian point 1. It's about 1 million miles away from Earth. Discover showing a much denser solar wind there at about 9.5 protons per cubic centimeter, but a similar solar wind velocity at 480 kilometers per second. So it's still elevated. And yeah, them's the facts. Them's the facts. Next, the GOES magnetometers here. Very tight range for the past 24 hours. Very high lows and very low highs for the past 24 hours. Now, the GOES satellites are located at about 23,500 miles of altitude. They are geosynchronous near equatorial orbits. They kind of wave back and forth over the equator in like a sort of like a figure 8 pattern sort of a thing. And it's just after noon local time for the GOES. That's the GOES 18 represented by the blue line. The blue N means noontime local time for the satellite. Next, our top view ecliptic plane field plot. And Earth looks like it is still in a North Pole-oriented magnetic heliosphere sector. There it is in green, and it's going to stay there for a couple days, it looks like, unless we see some drastic changes, which indeed can happen in the magnetic environment. But at the moment, Earth remains toward the middle of a North Pole-oriented magnetic sector. Next, our line-of-sight field plot. And that's one of the most important data sets that you could possibly ever view, folks. It's got a lot of information in a little bit of pixels. So, photosphere magnetism depicted in gray, solar B field in blue, polar fields in green for north and red for south. It's a 4-day snapshot of the magnetic environment that is the closest star. Next, our line of sight coronal hole plot, and North Pole oriented coronal holes here rotating in with some South Pole coronal holes there rising up over the east. So it looks quite volatile over there in the east once again. And let's take a look at coronal holes from SDO. There you go. There's 211 angstroms. So basically what you've got is North Pole coronal holes in here, and then some South Pole coronal holes over here in the east. So that's the scenario. And let's get the sunspots, which are still over 160. So there's our sunspot number from Rob, the Royal Observatory of Belgium. Sunspot number currently at about 161, a little uptick since yesterday, but still above the current average, which is about 141. So again, the radio flux all the way up to 209 solar flux units, a huge uptick in the radio flux. And let's take a look at our flare probability monitor and scoreboard. But first, the synoptic map. There you go. There's our synoptic map. And we have a proton event that's going on, so this should say 100%. The likelihood of an X-class flare, 25%, is calculated by this forecaster. And not sure who that is, WC, I think. And lots of filaments on the Earth-facing portion of the solar disk, lots of prominences hanging off the edge of the solar disk. It is an exciting time for space weather. Likelihood of an M-class flare, 75%. Likelihood of an X-class flare, 25%. Here's our flare probability monitor and scoreboard. And once again, the most active sunspot is actually behind the northeastern limb. So up here is the most likely place for an X-class flare. We still have sunspot 3576 and other magnetically complex sunspots on the Earth-facing portion of the solar disk. Again, it's an exciting time for space weather. Here come some sunspots from SDO. There's the SDO magnetogram, relying on polarized light in order to determine the magnetic polarity of those regions in the photosphere, the sun's surface. And we're terribly sorry if it's controversial to say the sun has a surface, but more and more people are starting to believe stars are not made of gaseous plasmas. Next, the SDO continuum, and man, those are some beefy sunspots and quite a lot of them. So that's what 160 sunspots looks like, and it's actually been increasing here. So those sunspots in the north especially have been growing since yesterday, just steadily growing. And let's take a look at some more data here. So major proton event continues here. We've got massive radio blackouts over both polar regions, also around the equatorial region, because we've seen a huge uptick in the background X-ray flux. So for the past 12 hours or so, the background flux is something like a C6 or 7. So big uptick in solar activity here, especially the radio flux and proton events and incoming CMEs. Again, it's an exciting time for space weather and for the channel and for our viewers. So we're always excited to bring you exciting information. So major blackouts there happening as the ionosphere gets ionized and hence attenuated by incoming radiation. So there's that proton event, and another one struck this morning at the same time that another CME is headed this way. So a big uptick in all the different energy levels there, all the way from 10 to 100 million electron volts. That's the GOES proton flux. And it looks like it may have topped out here. Let's look at the 6 hour. It looks like it may have leveled off there. So yeah, significant radio blackouts caused by d-ionosphere layer attenuation by those protons. And of course the X-ray flux, as you can see, it's just been steadily rising throughout the day today. Multiple M-class flares in the past 24 hours make it five M-class flares in the past 24 hours. And let's take a look at SDO. Once again, there is the spectacular 94 angstroms wavelength. And again, the most active region is up there in the northeast, your upper left screen. but multiple large and magnetically complex sunspots litter the Earth-facing portion of the solar disk. The likelihood of major solar flares, including X-class, it's a 1 in 4 chance, according to WC. And wait till you see this awesome imagery of this northeastern limb. So that ain't half bad. That's 131 angstroms, a 24-hour video at 30 frames per second from Solar Dynamics Observatory. And we're also going to show you the 94 angstroms. Dag! That is some bulky activity. And we're not even at solar maximum yet, folks. We've got another like 8 months for solar maximum to arrive, which means you can expect like 16 more months of activity levels consistent with what you're seeing now. Facts. Somehow they remain controversial, even in the year 2024, even following the pathetic last 4 years on our planet. Anyway, let's take a look at a star chart next, as I'm always interested in what's going on overhead, so maybe you are too, so ta-da, there you go. If you're viewing the early night sky, you may see Saturn, the Moon, and Jupiter up there. 3 of the brighter objects visible from the planet. Next, the solar system forecast from theplanetstoday.com. There's where things are today. There's where things will be in a week. We'll have a gibbous waxing moon, as Earth is in a lonely side of the solar system. No planets over here. Not even terrestrial planets, much less gas giants. Next, the astronomy photo of the day, which is a planetary nebula. Now, that particular planetary nebula features a white dwarf and a red giant that are orbiting each other's common center of mass. And that is a reflection nebula. You've got a bunch of gas there that's moving away from the stars, and it's also interacting with the interstellar medium. You see this bow shock-like region right here, as this whole thing is kind of moving in this direction. So, pretty cool nebula there. The astronomy photo of the day. Check it out yourself if you like at apod.nasa.gov. And let's get to CMEs, since it's definitely going to be an important story, coronal mass ejections. So here are today's images from George Mason University, and that early one that you see out of the lower right, that does have earthly directed components once again. So that's 5 coronal mass ejections headed this way. You can expect them to start arriving maybe even later tonight, but certainly by midday tomorrow, expect some significant geomagnetic storm conditions. You may see some breakdowns of some communications as a result of that, so just keep an eye out for that, and maybe you'll be able to impress your friends and foes by saying, hey, I think that internet outage was caused by a satellite linkage, which lost communications as a result of geomagnetic storms. It can happen. And let's take a look at some more coronagraphs here. We'll also look at C3. Let's just zoom in. Dag! And look at all the snow on those coronagraphs. Those are relativistic particles. So, once again, a significant proton event struck this morning. Let's let that catch up a little bit. So right here, you're going to see a major CME out of the lower right. And there it goes. Or should I say, here it comes, because it does. Now, the more spectacular one is actually out of the upper left there, the northeastern limb. That's from behind the limb. That does not likely have earthly directed components. There it goes. An absolutely massive CME. And then another one kicking off as we make the video. That one is up in the northwest. So let's bring this back to the one that is earthly directed. There you can see a partial halo there. So make it 5. CME's on the way. And before we look at our custom coronagraphs, let's take a look at stereo A. So there's our stereo A coronagraph and difference imagery on the right. So here you'll see early this morning at about 7 o'clock, kazam! There's a CME out of the southwest, and then more events, and more events, and more events, and more events, and here come our custom coronagraphs. So pretty busy times when it comes to space weather. We've synced together the SDO 304 angstroms wavelength, the LASCO C3 in blue and the C2 in red. Good times for space weather. How you like them apples? So we've got a snowstorm coming to Pennsylvania and a geomagnetic storm coming to Earth that might not subside for days. Here we've dropped the C3 and added 193 angstroms to the SDO imagery there to add a little bit of additional contrast to those plasma filaments. So yeah, that's what's up. And here's an extreme close-up. Again, that latest CME that's headed our way came from this area right down here. Most will miss to the southwest. A large portion will strike. Facts. Still controversial in the year 2024, somehow. So here's a little closer view of this series of events in the northeastern limb. And how about if we... There we go. There's a still frame. Just to give you an idea of the scope of a large coronal mass ejection and solar prominence. I mean, this is before it's even diffusing out into the solar system, so that's when it's still very, very dense. As you can see, it's millions of kilometers in size. Let's bring that back. Not too shabby. And of course, we realized years and years ago that we would need to have more substantive stuff than just trying to get oohs and ahs with solar imagery. We were interested in doing stuff like advancing the science. You know, figuring out things like the solar sunspot cycle. Of course, I almost majored in cosmology back in the mid-1990s. I just didn't really want to go to school for another 6 years or something like that, so there was no way I was going to be doing that, as I didn't want to be measuring Cepheid variables for NASA for a decade with my 4-year astronomy degree. So, of course, stellar cosmology is now a major that's actually offered at places. Back then, I think there was only one school that offered it, like UCLA, and there was no way I was going to the West Coast either. So anyway, check out the filaments on the closest star. Lots of them, and lots of prominences, which are just simply filaments that are hanging off the edge, which are visible in this imagery from Cerro Tololo, Chile. The non-prominentiary filaments are a little bit better viewed through the colored imagery that we're showing you now. So massive filaments, and this one down here, I'm about to name this one the Pierre-Marie Robitaille filament. Because if more CMEs are headed this way, that is the most likely one. So if you want to name filaments, do it over on X, otherwise known as Twitter, which is an actual brand. So x.com/smashomash, just follow the hashtag name that filament, name filaments after your friends, foes, and perhaps even yourself. We're about to close out the space weather section, but first, bonus features. As you can see, more activity happening up there in the Northeast, and that's not stopping anytime soon. It remains the most likely place for an X-class solar flare, so eyes on this region. Don't worry, folks. We'll be monitoring it for you. As if that's going to do anything. Anyway. So, yeah. DAG. That's the past couple of hours from the GOES 16 SUVI. Let's shrink it down so you can see the time stamps. That is an active star. 209 for the radio flux. Over 160 sunspots. And the activity ain't slowing down anytime soon, folks. If anybody's told you the sun's shutting down, their channel should be shutting down. You know who you are. Anyway, Next bonus feature, satellite charging hazards are first. We ain't got none at the moment. It's smooth sailing for satellites. Goes electron flux, coming up off the floor, and it's about to be cratered. Now keep in mind, folks, when that gets cratered because of a geomagnetic storm impact, it's actually erroneous because the ionosphere puffs up. It puffs up, and because the GOES 16 and GOES 18 are measuring the F layer, the electrons in the F layer, they use radiography from their very high geosynchronous orbits, and so when you see that get really, really low for extended periods of time during geomagnetic storms like from coronal hole high-speed streams or CME impacts, it's actually erroneous, but it helps with space weather forecasting because it's a data set. It's just that the altitude of the F layer is changing as the ionosphere puffs up when incoming space weather happens. Anyway, there's the 1-year graph of the relativistic electrons, the 2 million electron volt electron fluence or flux. Solon.info once again. And there is the forecast model. Now, NOAA's forecast looks completely outlandish and berserk. All right. So these next couple days here, that's not going to be right. Okay. Like those high levels are kind of unlikely to be happening during a geomagnetic storm. So we're expecting to see very low levels there. Again, erroneous readings are likely. But, based on the extended high-speed stream that we've had, so, we should have a high level of electron flux, but we're probably not going to because of those erroneous readings I talked about earlier. Anyway, we'll also show the F layer. The F layer. Don't be effed. Realize that it's at about 300 kilometers of altitude. So there's a diagram. Feel free to pause the video on this frame if you're not familiar with that. Here is the vibrational frequency of that, and you can expect to see a lot of low-frequency anomalies in the ionosphere coming in the coming days. So the next 3 days, you're going to see a lot of low frequency on there. At the moment, things are still looking pretty normal and average for the ionosphere. Don't expect that to continue. It's only 5 coronal mass ejection impacts on the way in succession, rapid succession. So here's the anomalygram. That's anomaly in megahertz from the 30-day median. So in the next 3 days, you're going to expect to see a lot of red on this if you understand how the data correlates with reality. At the moment, like I said, things have been quite calm. So not a lot of anomalies, but a lot of anomalies coming. We'll also show the global ionosphere nowcast, or WAM, the whole atmosphere model. And we'll close out with the latest imagery. Some high-res images here. And let's take a look at the magnetic fields. There's Sunspot 3576, still beta gamma delta class, but barely. That group up there is beta gamma delta class. Very nice. And that group over there is beta gamma delta class. But the major player is this group that's rising over the northeastern limb. It only looks like it's beta class so far. But in fact, it might even be alpha class. Let's check. I don't think it's alpha class. I think there are more umbrae trailing it there. But anyway, let's just show the full disk image and move on to meteorology, because there's some interesting meteorology stories as well. So first thing we're going to show is the sea surface temperature anomaly and surface winds. So there are surface winds. You can see this low pressure right here, right over like Kentucky, Tennessee area. Again, that sea surface temperature anomaly. In color gradation, the animation is the sea surface temperature anomaly. So sea surface temperature anomaly and surface wind speeds are what are depicted here. There's the Atlantic Ocean. There is the Southern Ocean. Indian Ocean here. The Arctic. And the mighty, mighty Pacific. Earth's largest surface heat sink. It's water. It's not just water, it's a lot of water. And water has a very high heat latency. That's why we use it for things like water heaters, because it retains heat. Anyway, let's get to our regularly scheduled meteorology segment. There are the surface winds of the eastern world. There are the jet streams. There are the jet streams of the central world. And there are the surface winds. Surface winds of the west, aka the Americas. And there are our jet streams. Still have a very far south jet stream, especially over here around the Pacific, and that is bringing a bunch of moisture across Mexico, across the U.S., and straight to my doorstep. Anyway, here are clouds and fog for the Americas. Some rapid cloud nucleation happening there in southern South America. Also over Brazil. In Brazil, the sun sets and the clouds come out and the lightning begins to strike, like every day. So there is clouds and fog for the U.S., and here we'll do a little close-up since we have this low making its way across the country. Of course, it will be a nor'easter, and we're always excited about snow here at the Smash News Network. Least busted name in news. I work remotely, which means I don't care in the slightest about snowstorms. In fact, I can act like a kid and go, let it snow, baby. Let it snow. I'm stoked about it each time it happens. Next, I just wanted to take a look at this windy.com map. So windy.com's got a great mobile app that you may want to download if you like. And I just wanted to show the ozone map. So this is actually showing you what's going on in the stratosphere. Of course, ozone is the dominant chemical component of the stratosphere. And what's interesting here is you may think this is a hole in the ozone layer, but actually this down here, this is the hole. So that's actually a very thin ozone down there. Up here over the northern hemisphere, we've got actually very high levels of ozone. So there you go. Yeah. That's what's happening with ozone. Lots of it over the northern hemisphere, not so much over the southern. Anyway, here's our weather.gov map. Weather.gov is where to get your weather warnings. Some flooding in the forecast there for the southeastern U.S. And a bunch of weather warnings there. Too many for us to cover. So if your location is lit up on the map, weather.gov, the homepage of the National Weather Service. And here comes some forecasts, starting out with the GFS 72-hour. GFS 72-hour pressure and precipitation. You can see that snow is going to be quite heavy and quite wet. So there's that. Here is our positive accumulated snow depth change in inches. More snow coming to California. Anyway, a picture says 1,000 words, so I'll say less words. Next, accumulated total precipitation in inches. And it's a little bit milder than what we saw yesterday, although some of that rain has already fallen in the southeastern U.S. Some more heavy rains coming to Oregon, Northern California. Well, you see the map. That's why we're showing it. 72-hour GFS forecast. And the 72-hour GFS temperature anomaly forecast is next. And let's take a look at the culprit. Do you know what the culprit is? Do you know what's in charge of moving weather from west to east? Well, it's the jet stream. So the 250 millibar winds counts. If you're using the nullschool.net map, it's a 250 hectopascal, or hectopascals? Hectopascals. Essentially the same thing. One is pressure and one is based on inches of mercury and a barometer, and I'm not going to get into it, but there you go. There's the jet stream forecast. The jet stream is staying really far south, but at the end of the next 3 days, it will start moving up to the north. It's going to bring some warmer air to the northeast once again. 72-hour jet stream forecast. And we've had some terrestrial lightning. So there's about a 10-hour map of lightning. Southeastern U.S. seeing some. And here's a real-time lightning map. Do we have any terrestrial strikes in the U.S.? It doesn't look like it. Lightningmaps.org is where you can check next time you hear thunder. You can even forecast the thunder. And it looks like a little bit here around Wakasasa. There you go. Some strikes there in some seriously estuarial-looking regions. Some ocean swamps, essentially. We'll close out with Doppler radar, clouds and fog, and water vapor, as we're known to do on the channel. So there's our U.S. Doppler radar map. There's all 50 states. Here is the lower 48, which is what we'll focus on. There is clouds and fog, and there is water vapor. Here's a recap. Some heavy metal weather there moving across Kentucky toward Ohio as we create the video. Clouds and fog depicted by the 3.9 micrometer infrared shortwave radiation satellite and 6.61 micrometers infrared radiation depicts the water vapor. When your Doppler is unclear, the water vapor map will deliver you from ignorance. Remember, folks, ignorance is the root of all knowledge. You can't possibly know a thing until you didn't know it. You have to not know it, and then you know it, which is why ignorance is the root of all knowledge. Anyway, we'll see you soon here at the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.